Welcome back. We're on the 2019 Calculus AB FRQs, and today we're going to be working on question number 2. So, and in question number 2, we do have a calculator with us, right? It's allowed. So here we have a function f of x, and we have an equation, a pretty lengthy equation at that. And that equation is evaluated from 0 to 3. Then we have a mystery function g. We just know that it's continuous and it's decreasing from 0 to 3. And we also know that g of 3 is equal to 0. Okay. The figure above on the left shows the graphs of f and g. We have region R, region S. Region R has an area of 3.24. Let me go ahead and label that because I feel like I'm going to have to use that later on. S is the region bounded by the y-axis and the graphs of f and g. We also have a second graph that shows us g of x squared, and that's region T. And we know it has an area of 5.3. Well, 5.32021. Find the area for region S. Okay, so for part A, since we're trying to find the area for region S, all we got to do is integrate, and we're going to have to do top minus bottom. So the integral from 0 to 3 of f of x minus g of x dx. Okay, the setup alone might already get you a point, so make sure you know your setups. And because this is a calculator portion of the FRQs, you can actually just integrate f of x on its own. Especially because we don't know what g of x is. We don't have a function to plug it into our calculators to. But f of x gives us an area of 8.1608. And we don't even have to know what g of x is because they already told us what the area is. The area is 3.24125. Oh, it looks like my video is a little laggy, huh? Hopefully it fixes. Well, the final answer is 4.91958. Okay. Oh, another recommendation. Don't forget to write dx for every single integral that you guys write. Every single integral has to have dx, dt, or whatever variable you're integrating with respect to. Okay. Find the volume of the solid generated when S is revolved about the horizontal line y equals -3. All right, let me go back to the graph. If I have the horizontal line y equals 3, which let's say that it's somewhere down here. This is going to get a little messy because I have the problem right below it, but you're basically going to be doing a revolution. And that creates a reflection. So something like this. It's not perfect, but it's kind of something like that, where this is shaded, and that's being revolved around the horizontal line, -3. And that's going to create a washer. It creates a washer because we have all this empty space. Empty space. So, since we're dealing with a washer, the volume is going to be given by the integral from a to b of pi r squared minus pi r squared dx. You know you can factor out the pi. And we are doing the integral from 0 to 3. Now the big radius, let me rewrite this. The big radius is top minus bottom. If you look at your figure above, the top function is f of x, and the bottom function is -3 squared minus the little radius Here, let me show you guys on the graph. The little radius is given by the distance from the center of the circle to the closest function, which happens to be g of x. Oh, there we go. It's taking a while to load. There it is. That's the small radius. So to find the length of the small radius, once again, you do top minus bottom. G of x minus -3. So the little radius, top minus bottom, g of x minus -3 squared dx. All right, that's the setup. This already gives us 2 points out of 4. But we want to get those last 2 points. So let's go ahead and work this out. The first integral can be done with the calculator because we have a function for f of x. But the second integral, oh, you know what? I'm going to put brackets here because I'm creating 2 integrals. The second integral, that one's going to be a little tricky since we don't actually have a function for g of x. We're going to have to get a little creative with that. Okay. The calculator gives me, for the first integral, it's going to give me a value of 15.1099 minus. Give me a second. Hello, Ron speaking. Yeah. Okay. Well, I guess I'm gonna have to redo the video, but I'll finish it with you guys right now, just so you guys can finish the problem.
Oh, it stopped in the boundary?
Oh, it's gonna be you in my future classes. We're gonna go through the same packets.
Oh.
Since we don't have a function for g of x, we're actually gonna have to FOIL this out. We're gonna have to square it. And if you square g of x plus 3, one of the biggest mistakes students make is that. It's loading. 9. That right there is wrong. Because it's not. It's supposed to be g of x squared plus 6g of x plus 9 dx. That's the correct version of g of x plus 3 squared. Yep. Now for this is going to get a little messy, but you have to keep writing everything down. This is 15.1099 minus this whole polynomial. You can think of it as 3 separate integrals. And I'm going to write it. I'm not going to be lazy because if not, things are going to get messed up. Minus the integral from 0 to 3, 6 g of x dx, minus the integral from 0 to 3 of 9 dx. Close the parentheses because pi is still affecting everything. Now, go back to the graph. Do I have a value for g squared? The integral of g squared?
Yeah.
That's the other graph that they gave us, right? That's t. What's the value for that? Okay. Give me a second. I'm gonna have you give me that value again. 5.32021. Okay, that's given by t. The next part, the integral of g of x, we're also given that one. That's region R, which is 3.2 24,125, 24,125, 24,125. And then finally, the antiderivative of 9x, evaluated from 0 to 3, that's 27. And close the parentheses. And at this point, just plug it all into the calculator. No, that was given to us. Go back to the first. It says that the graph of, it's the second graph, something about g squared. Right there. That's g of x squared. And they told us it was 5.3. Blah, blah, blah. No, that was already squared. It was 5.32021. Then you plug all of this into your calculator, and then you're going to get some final answer, which is 156.264 units cubed. What you should be taking away from this FRQ, especially this little tricky part, is that when you're doing an integral, sometimes you need to simplify that integral, right? Like in this case, it was squaring it. Like, and that's the case if you're dealing with other functions. Like, say I'm trying to tell you to find me the integral of x plus 1 squared dx. Well, you should know that you could always actually square it and then find me the antiderivative. That's the takeaway from something this difficult. Getting the antiderivative for this is much easier than getting the antiderivative for that. So simplifying the inside portion is always something that's pretty useful. All right. The last one. Region S is the base of a solid. And for this solid, ahorita, right now, I'm still technically recording. Even though I'm going to redo this, keep silent, because I'm still going to post it for you guys temporarily, so you can have something to look back at. All right. So region S is the base of a solid. Each cross-section is perpendicular to the x-axis. It's a rectangle. Let's stop right there. You need to know your setups for volume given cross-sections. So, how do I find volume given cross-sections? The general setup. The integral from A to B. No, you're getting specific. I don't want specifics, I want general right now. No. Huh? A of x? Yeah, A of x, dx. Where A of x is the area of whatever shape you're given. Now we're getting to the rectangles. Now tell me what the area of a rectangle is. Base times height, length times width, whatever you want to call it. And we're doing the integral from 0 to 3 because we're talking about region S. Now it says the rectangle has a height 7 times the length of the base. So we can take the height and replace it for 7b. Yes. The 7 can come to the outside and you can simplify it to b squared. So now that just means we have to figure out the base of this rectangle at any given time. Let me go back to the graph. Region S can have, this could be the base of the rectangle at that moment in time. This other line could be the base of the rectangle. How can you define that length? Top minus bottom. F of x minus g of x. So the volume equals 7. The integral from 0 to 3 of top minus bottom, f of x minus g of x, squared dx. We don't even have to evaluate it. We just leave it. That's why throughout the whole school year, I told you every single time, write your formulas down first. And a lot of times, we jump straight to like plugging in numbers. No, plug in. Get the formulas down first and work it one step at a time. Like, find me something for that formula to like substitute. That's a 2. If you write your formula, first off, you'll remember it. And then 2, you'll probably get points along the way on the FRQ for the setup. But yeah, that was question 2. Later, I'll give you guys